The new section for today is going to be 5.7, the Slope-Intercept Form. And you're going to recognize this thing for sure. This is basically going back to the y equals mx plus b. Now I'm going to take and write that real big in red for dramatic emphasis and put a big box around it. But this is the slope-intercept form. It's the most common equation for a line. It's the most popular. It's also, in most situations, I found the most helpful. So this section here is going to be real pivotal because this equation is going to keep coming back over and over and over. So try to master it right now. And want to point out kind of like what the different parts in it mean. So we have the name here, the slope-intercept, and this m, and we'll kind of show this really soon, but the m is going to be the slope. That if you have x changing by 1, when x is multiplied by a number, y is going to change by that number every time. So m automatically becomes the slope because that's what x is multiplied by. The second thing over here, this b, we've been kind of doing problems where you're trying to find x-intercepts and y-intercepts and stuff like that. Our name is the slope-intercept form. B is going to be the y-intercept. So if you're graphing, you can just take whatever number is there after the x, the number that's by itself, and that'll be where the line crosses the y-axis. In addition to that, what it really is going to be, every time you have like story problems, if you have a story problem that gives you in a starting amount of something, someone's salary before they sell anything, the number of things in someone's collection, the number of hairs on someone's head before they start losing their hair, all this kind of stuff. But the y-intercept is always going to be the starting amount. And that makes this equation really nice when you're doing story problems. And a lot of story problems, not all, but a lot will fit this equation. So if you look at your list of I can statements for this section, you're going to notice that I expect you to know this thing from memory by the test. So I would start out all your problems that you have to use this one, write out y equals mx plus b. And then when you get to the test, you're going to know it from memory solid. But this is called the slope-intercept form. That's another key thing. So I'm going to ask you to write it by name. You need to know that this is the slope-intercept because it has the slope and the y-intercept in the equation. So I'll maybe quick add in here no for the test. And just so I make sure I'm kind of doing a decent job explaining it, I'm going to quick throw an example down here. You're welcome to skip it, but if you were to have like a y equals 2x plus 4, kind of what am I getting at? Well, if I were to take my equation and say, alright, my equation is y equals mx plus b, the y-intercept then, where it crosses the y-axis, would have to be a positive 4. So it would be 0, 4 would be my y-intercept. So if I were to be graphing this thing, maybe we'll just go with a quadrant 1 graph. I'd have my y-intercept being right there. And now the slope is going to be a 2. So if I wanted to go through, so m is going to be the slope. If I wanted to find out more points then, rise over run, slope is 2 over 1 in this case. I go up 2 and over 1. And I could go up another 2 and over another 1. But we'll do this in a little bit better job soon. So, ooh, kind of an ugly line I drew there, but work with me. The other place you could kind of see that same information would be if we would put that into a data table. And in a data table, if we have our x and our y, well, we know that we have the point 0, 4, so that's our y-intercept. And you could just go through and plug numbers in. Like you could say, alright, I have an x value of 0, put a 0 in there for x, 2 times 0 is 0, add the 4. But then if I'm going up by 1 for my x values, you could keep doing that same thing. Now I put a 1 in for x, then I put a 2 in for x. But the other option would just be to know that, well, every time x goes up by 1, y goes up by 2 because the slope is 2. So I'd have to have the point 1, 6 and 2, 8. So that's kind of applications of this. But want to go through and actually do a couple story problems. Maybe I'll flip to a new page here. And I'm going to call this my Roman numeral 1, so I didn't label the thing before as anything. I'm just going to say writing equations. And I'm just going to jump right into an example here. and say, write an equation for a line with a y-intercept of 1/2 and a slope of 3. And you could, instead of having this be written out, you could be given a graph and then have the graph say write an equation for a line. And like I'm trying to encourage you to do, I'd start by, well, just write y equals mx plus b. And if you wanted to, your equations typically always are going to have the y and the x in there still. So you could even write those out if you want. Now you just need to put in a number for m and for b. So the y-intercept is 1/2. Well, the y-intercept is our b value, so I'm going to add a plus 1/2 after my x. And the slope is 3, and m was our letter for the slope, so you could just put a 3 in there. And here we have an equation for that line. So that would be what one of the I can statements is talking about, being able to go from a description of a line or a line into the equation. And want to then jump to another example, so I'll say, okay, my next example would be this. So let's say you have 326 songs on your iPod, and instead of buying albums, let's just say you buy 3 more every week. So write an equation showing your number of songs. We'll call that y in x weeks. So write the equation showing y songs in x weeks. So you have 326 songs on your iPod, you buy 3 more every week. Write an equation showing y, the number of songs you have in x weeks. So for doing that, I'm going to start out just by writing y equals mx plus b. And I guess you could put in your y and your equals and your x. So we really just need to fill in an m and a b. And if you go back to what we were saying at the beginning of the notes, b is always that starting amount. Well, you start out with the 326. So 326 goes in there for the b. It's a positive number, so it'll be the plus 326. And now if x is our number of weeks, every time x goes up by 1, you need to have y go up by 3 because you buy 3 songs every week, which then would fit that 3 would be the slope. Because for every time you add 1x, y goes up by 3. And that would be another one of the I can statements, being able to take a story problem and pop it over here into this equation. Then the last part we're going to do hits that last I can statement, and it's going to be taking and graphing these things here. So I'm going to start out with a Roman numeral 3, actually Roman numeral 2, and say graphing lines given by y equals mx plus b. And you're maybe thinking, it's like, I've been doing this for years. Yes, you have. You've been doing it the slow way, though, for years, probably. You could take your equation like this, put it into a graphing calculator, do a table function that would give you the points to put on a graph. You could pick some x values, put them in, and find y values, get a couple points, draw a line through it. But this here, I'm going to say is the fastest way to do it. So I'm a big fan of steps, so I'm going to say, alright, here's the steps I'd recommend you do. First thing, you know the y-intercept. You know that right there. And make sure you pay attention to the plus or minus. That's going to be the y-intercept. So I'd start with that and put a dot on the y-intercept. And then once you have that, we now know the slope. because my m right there is going to be the slope. So I'm going to say find points. I'd recommend making that plural. Sometimes people just find like one point that's real close, but then by the time you draw your line, it's off by the end. So I'd say find some points using the slope. And especially if the slope comes out to be something like 2, just want to kind of refresh your memory that slope is going to be rise over run. So if you have a slope of 2, it's really saying 2 over 1, that you need to go up 2 every time you go 1 to the right. If you have a negative 2 for a slope, well, now you go down 2 and then 1 to the right. And I'll erase that because that won't make sense if you're looking at this later. And then third step is you draw a straight line through the points. So straight line through the points. And when you draw your line, make sure you put an arrow on both sides because that line should keep going for forever. So I want to do a couple examples of those. I'll give you a second to finish writing that. And so I'm going to do 2 examples. And I throw some graph paper in there. My first example I'm going to do is y equals negative 2/3 x plus 4. So I'm recommending that you start out with your y-intercept. So you could, I suppose, if you wanted to, write y equals mx plus b in there, but we'll just jump ahead and say, okay, my b is going to be my 4. And it's a positive 4, so I can count up 4. 1, 2, 3, 4. So right there is going to be my y-intercept. And now my slope is going to be this negative 2/3, so I have rise over run. So my rise is going to be negative 2, so I go down 2 for that. My run is a positive 3, so we're going to work over in the positive x direction. So I went down 2 over 1, 2, 3. So now that's going to be a point on the graph. And I could go down 2 over 3, down 2 over 3, down 2 over 3. So I should be real good in this direction. What you might want to do is do the opposite, that negative 2 over 3 is the same as 2 over negative 3, because it's equal to the same number. So you could look at it as though you go up 2 and then 3 to the left, kind of your negative 3 for x. So you could get a couple more points that way if you wanted to. And once you have that done, now you can go and try to draw a nice straight line through those points. And again, make sure you put an arrow on both ends of it, or I'll mark you off a quarter point and make you all mad. So that'd be one. And want to do a second one that just has a couple little tricks in it. That way you don't get caught unaware by the tricks in the homework. So my last example for this section is y equals 3x minus 5. And I'll maybe write out my equation underneath there. So y equals mx plus b. And the reason I wanted to write that is you could see this y equals 3x minus 5. Well, that's the same as y equals 3x plus a negative 5. So be real careful when you have a minus in there that you need to make sure for your y-intercept that you go down 5, or down whatever the number would be. So that's my starting amount. Negative 5, here's my y-intercept. And now my slope is 3. That's the second trick I tried to throw in there, where if you're saying slope is rise over run, well, 3 is the same as 3 over 1. So then I could, alright, if I'm using that as my starting point to find my slope, I could go up 3, and then 1 to the right, up 3, 1 to the right, up 3, 1 to the right, up 3, 1 to the right. You could do that same thing in the opposite direction. You could say, well, I'm going to do, instead of positive 3 over positive 1, I'm going to do a negative 3 over negative 1. So I go down 3 and then 1 left. But if you find a decent number of points, now you should be able to draw a pretty good line through those points. Throw an arrow on both ends, and you're done. So that wraps up this section. Good section to really pay attention to, because this is going to be a really popular thing that you continue doing through algebra and geometry in Algebra 2. Thanks for listening.